This conference will now be recorded.
Good morning, one and all. Myself, Durga Prasad, Associate Professor in the Department of EC, and in this semester, I would like to handle a subject called Data Communication and Networks. Right. Before I go into a detailed study and I explain about data communications, let us try to understand these three terminologies called data, communication, and networks. To understand these terminologies, let us try to take a simple real-time example. Like you are trying to send some information to your friend on a WhatsApp. Okay, so when you want to do some chat on WhatsApp, what are the different things that you can send your friend? For instance, you would just like to say hi or good morning. It's in simple form of a text. Or you would just like to share him some image. It might be something like your pic which you have taken, or it might be an image of a webinar details which you would like to share, or something like a joke or fun clip image kind of things that can be shared, right? And sometimes you may try to share a video which you have received from someone else and felt very good and interesting, and you would like to share with your friends. Or you want to send him some voice message asking him to call back after some time. So it may be a text, it may be an image, or it may be a video, it may be audio. Or sometimes if you're trying to play to an online Ludo King and you want to share him the game code, so here you can send some numbers. So information, whatever maybe you're trying to transmit, will be referred as data. And what is the purpose of generating data here? It's not just for yourself. You want to exchange the information with your friend. Now, the sharing of the information or exchanging of the information, we actually refer as communication. And for communication, we need a path. And how can we this data can be communicated to your friend? And to implement this, we require something called as network. A network will help for the communication of data from you to your friend. And here, the one who is sending the data, we refer him as a sender. And the person to whom we are intending to send, we call him as a receiver. And the exchange will be referred as communication. So let me simply give an definition of a data communication network as a network used for communication or exchange of information from a sender to receiver. Now, this is the whole idea behind the learning of this subject called data communication networks. But we need to understand what is the exact process, what are the elements involved, how exactly the data has been exchanged, what are the protocol or what are the elements which are responsible which are for the exchange of this information. Everything need to be taken care. So we need to understand all these prospects in detail. So that is what we are going to learn in our subject called data communication networks. So first, let us have a quick understanding of what are the different objectives that we would like to meet using this subject called data communication network. Right. Through this subject, we would like to achieve some of the objectives. What are that? First, we would like to introduce you people. What do you mean by data communication? What are the elements? What are the components? And how the data will be exchanged? At the same time, what do you mean by a network? And then what are the different types of networks? How the networks communicate using different models? And then we'll also try to understand one of the more familiar application which we have on your mobile phone called internet through Wi-Fi. We'll try to understand the working principle of Wi-Fi, which is technically referred as 802.11. This is our first objective. Coming to the next objective, while sending data, there is a possibility that the data might be corrupted due to the noise or some other factors. So first we need to, when we receive the data, we need to understand whether the data received is correct or not. Correct? Well then, in case if you're trying only to find if there is any error or not, we refer it as error detection. But when you are trying to understand if there is any mm, not only the detection but also correction is required, then we call it as error correction. So your data link layer, which is your second unit, will try to understand about error detection and correction. At the same time, we would also try to understand the various functions which are performed by your data link layer. Okay. Then coming to the third unit, we would be third of unit, we will try to understand an object of how a data will be transmitted from the source to the destination. Actually, the way the data is exchanged will be referred as routing. So the routing of data is performed by one of the layers called as network layer, which we will try to understand in unit number 3. The fourth objective here is to understand not only the data has to reach to the destination, but also it has to ensure it reach to the application to which we are exchanging. For instance, we referred earlier about WhatsApp. So when I'm sending an information or a chat in a WhatsApp, I have to send that particular information to the WhatsApp of my friend to whom I am intending to send. So not just his phone, but the information has to reach to the WhatsApp application on his phone. Now this is called as process to process delivery, which we will try to understand in unit number 4. And we are just so far talking about only one application, but we have different applications in our real time. Like we would like to get some information, the first thing we'll try to do is we'll browse from the internet, right? So then sometimes you will be asked to send some information or some data to your friend. So you are going to attach some files. So you need some protocol to do that function. Next, sometimes we have been trying to what we can say. mm, we have talked about file, we have talked how to send a mail. Now I have just told you about attaching a file. We also need to send a mail. Again, for that we need certain protocols. So we will try to understand what do you mean by protocol, what are the layers, and how each layer will be helping us in sending the data from a sender to the receiver. So these are the few objectives that we would like to achieve using the subject called data communication and networks. First, to understand the fundamentals of data communication network, then to understand what are the various functions of the data link layer, then we'll try to understand how the data is routed using the network layer, then we'll try to understand how a process to process delivery is going to happen using transport layer, and along with that we'll also try to understand what are the various application layer protocols that help us in implementing number of functions, right? So these are the things that we would like to focus in our subject. I hope the objectives are clear. Now, after going through all these contents, what are the outcomes that we are going to achieve by using this subject called data communication networks? First, as I mentioned, we are going to have the different categories and functions of various data communication networks. What it means? First, we are going to understand what are the elements of data communication network, then how many ways that data will be exchanged between the source and the destination, and then we'll also try to understand what do you mean by a network and how many types of networks exist. Then we are trying to understand a very important concept called the models which are responsible for the exchange of information, right? All the fundamentals related with data communication networks we are going to learn through our unit number 1, and once they go through it, they can understand how this particular functions are being implemented, right? First we'll try to understand the concepts. After understanding the concepts, we will be able to understand what are the working phenomena and what are the things beyond helping us to make a number of things in our daily life, right? As we mentioned earlier, we want to make sure not only receiving data is important, but whether the data is received is correct or not is also to be verified, for which we are going to learn different types of error detection and error correction techniques. And people now will be understanding What are the techniques and how can I identify whether there is a presence of error or not in my data, right? Now, previously we were talking about data has to be routed from different devices like sources to the destination. Now, how that data is transmitted will be understood by learning certain mechanism called routing protocols and different algorithms associated with the routing, which we are going to understand in our unit number 3, and later people will definitely know this is the mechanism behind how I receive the data or how I transmit the data. Then we can explain people, yeah, I know it. What is the function of a router they find in their home, or they can talk about the switches which they find on the roads by the telephone exchange. All this kind of things which they find in the real time, they can understand the functioning and the role they play in the communication, right? So along with this, now someone may be interesting that what is the thing that was actually making them to receive the data on their apps. Then we'll also try to understand how we are able to control data from overflow. For instance, if I'm continuously sending information and my receiver is not ready to receive that, or he doesn't have that capability, what happens there? So definitely there will be an overflow or loss of data. To overcome that problem, we are going to implement something called flow control. So flow control ensures that the amount of data flown is in the amount of data flown will be in the limit of sender and receiver, and there will be no overflow. Then what do you mean by congestion control? To understand this terminology, let us take a real-time scenario like if everyone gets on the road and if the no signals are working, what happens? In a four-road junction, everyone would like to move ahead and definitely there will be a certain traffic jam created. So in this network, we call that issue as congestion. So to avoid congestion, we are going to adapt some of the control mechanisms. Those control mechanisms which you are adapting to overcome the congestion problem is called as congestion control, and people will understand how in a network this congestion has been managed. And last but not the least, they will be able to understand the different protocols which are responsible for the functioning of various applications, right? Fine. So far, when I've been discussing people with you about objectives and outcomes, I was talking about a terminology called protocol. But what do you mean by a protocol? In communications, protocol is a set of rules and procedures that actually govern the data communication. What to be done, when to be done, how to be done, everything will be explained by the protocol, right? So protocols play a very key role in the data communication networks, which we are going to understand along with different layers used in the two models which we are going to refer. Okay, so what are the outcomes that we receive? We will be able to understand what are the fundamentals of data communication networks. Then we are going to understand what are the different error detection techniques we have to find out whether there's an error or not. Then we are going to understand how the data is routed from the sender to the receiver. Then we are going to understand how do we implement flow control and congestion control. Last but not the least, what are the different protocols which are actually helping us in using various applications. So these are the course objectives and outcomes. Let us now just try to understand the syllabus which is a part of our subject into a bit detail. Okay, I hope I am sounding clear. Right. The first unit of our syllabus is called Introduction to Data Communications. So what are the different things that we will try to cover in Introduction to Data Communications? The first and most important thing we need to know is there are certain basic terms and definitions which we have to understand in data communications, and we are going to have a look on those basic terms. We will first try to understand what are the components of data communication, what are the different types of data that we have just discussed before the beginning of the session. Then what are the different data flows possible in data communication. Then we'll try to understand what do you mean by a network? What are the different types of networks? How do you evaluate network? Then what do you mean by a distributed processing? An evaluation of network is done by certain parameters called network criteria. And then we are categorizing our networks by using certain physical structures. Then we were talking about two important models which are helping us to understand what exactly the data communication network is implemented. So those two models are called as Open System Interconnection Model and TCP/IP model. TCP stands for Transmission Control Protocol and IP stands for Internet. So we are going to understand these two models, understand the different layers of OSI model, which is a 7-layer model. And in TCP/IP, we are going to understand the different set of protocols which help for data communications. Next, we are going to understand the different categories of network based on parameters like the distance covered or the number of devices connected to it, and how we are trying to establish larger networks. All this will be discussed in the categories of networks, right? After understanding what do you mean by a network, how do you measure a network or performance of a network, what are the categories, what are the structures of the network we have, what do you mean by interconnection of networks, then we'll go for one of the famous terminologies of this decade or this century called as internet. We'll first try to understand from where the internet was started, what is the purpose behind the starting of internet, and then we'll discuss about what are the different uh, organization structure involved in the implementation of internet today. Then we'll talk about protocols, and for internet to be implemented we need certain standards to be developed, and what are those standards developed, and what are the organizations behind the implementation of those standards, and the different internet standards and how they are being generated. We are going to discuss those aspects in the second part of unit 1. I hope we are clear. And third important, which we mentioned, that we have to understand in detail about the two network models which we have briefly introduced in our introduction. The first one is called Open System Interconnection, which is a 7-layer model developed by an organization called International Organizations for Standard, ISO, and a TCP/IP model which was developed by US DoD. Okay, so we'll try to understand these two models and then we'll try to compare the two models. Then in the OSI layer, we have different 7 layers, and first 4 layers will be dealing with different types of addresses, namely the MAC address, IP address, port address, and specific address. We will be trying to understand what those 4 addresses mean and what are their functions for. Okay, right. And last part of your unit 1 is one of the things which you have been using in our daily life. The first one, that is called IEEE 802.11, which is nothing but the Wi-Fi which we are using. So we'll try to understand about what is this IEEE Wi-Fi. At the same time, how do we measure networks called wireless networks or wireless links using parameters called the bit error rate and the data rate. I hope people with the usage of mobiles can understand the terminology called data rate. At the same time, we will also try to understand what do we mean by bit error rate in wireless communications, right? So these are the few things that we will be trying to cover in unit number 1. I hope people will got a small understanding of what they are going to learn, and definitely while we are covering the syllabus, we'll have a depth understanding of all these concepts. Okay, right. Now we'll try to go for the second unit. Right. We were discussing about OSI model in our unit 1 introduction. So in OSI model, we have 7 layers, namely the physical layer, data link layer, network layer, transport layer, presentation, session, and application layer. The second layer of this OSI model is referred as data link layer. When we recollect our course objectives, we were talking about a concept called whether there is an error in the data transmitted and received. So when we are trying to identify this, whether an error is generated or not, we are referring that process as error detection. But beside it, not only identifying whether there is an error or not, if we are trying to identify the position of error and then correct the error, we refer it as error correction. Let me just put you a simple example to understand this. If the data transmitted is 1, 0, 1, 0, and by the time data received, one of the bit got corrupted because of the noise, and it has been received as 1011. Now, at the receiver, the data received was 1011, but the data transmitted was 1010. Now, if we simply say that there is an error in the data, but I don't talk about what the error is, I just say that there is an error in the data, then that particular phenomenon will be called as error detection. So only specifying whether there is an error or not, we call it as error detection. But when I'm trying to identify the position where the error has been generated, here you could find that there is no error, no error, no error, and identifying there is an error in a particular position. So there is a small error at the last bit. So when 1010 was transmitted and we are receiving 1011, then we are trying to say that 1010 was what transmitted, and I have received 1011. Now, in error correction, what we are going to try to do is, we are not only saying that there is a presence of error, but we are trying to identify the position. And once the position is identified, we are trying to complement that particular bit. What do we mean by complement? Simple. If your bit data is 0, the complement of it is 1. If your data is 1, the complement of it is 0. So identifying the position and then complementing that particular bit position, we will be referring it as error correction. So there are different ways in which you are trying to implement error detection and error correction, which we are going to understand in the error detection and correction techniques. Okay, so this is one of the functions of data link layer. Along with this, data link layer receives the data from its higher layer called network layer, and the data which it receives, it is going to add a header and a tailor and convert the data into a format called frames. The process of converting the data from network layer to frames in the data link layer is referred as framing process. We are going to understand about this, the framing concept. Suppose this is my network layer data. And to this, I am adding a header, I am adding a tailor, and inserting this header total data into this part is your network layers data. Now this process is called framing process, and we'll try to understand what do you mean by framing and how the framing will be implemented and different ways of implementation. This is data link layer, and this is my network layer. So your data link layer receives data from network layer, adds a header and trailer, and converts into frames. And that process is called framing. We'll try to understand framing and different types of frames in our topic. Next, we were talking about error detection and correction, which is called as error control. The next thing we would need to ensure is flow control. As we said, if the sender is receiving at a faster rate than the receiver capability, there is an overflow or loss of data. To overcome this problem, we are implementing flow control mechanisms. Now, there is a small thing to be remembered. Now, between the sender and the receiver, we are trying to use a channel through which the data is transmitted. This is a sender. And this is my receiver. For instance, this is my channel through which the data is transmitted. So the channel between the sender and the receiver can be of two types. The first type is called as noiseless channels, means there is no noise during the channel. Whatever that has been transmitted will be received by the receiver. The other case, during the transmission, one is noiseless channel or noiseless channel, then the other one is noisy. One is noiseless, the other one is noisy channel. What happens here is when there is an exchange of data because of the external factors, a noise will be added to it. Then how do we implement the flow control? We'll be learning in noisy channel. This is one more function performed by our data link layer. And after this, one of the most important purpose or function of implementing or using networks is sharing of resource. So previously in this figure, we were talking about a channel. Now, it doesn't mean that the channel will be only used by one source and one destination. There is a chance that more than one device will be trying to use this channel to send the information from source to destination. For instance, this is S1 and I have another source S2 which would like to transmit data to destination. And remember, both S1 and S2 would like to use the same channel which we are referring as channel. This is a common channel through which you would like to transmit the data. This is my channel. Through which I would like to transmit the data. Okay. So when more than one device is trying to access the same channel, how the channel will be shared among them will be referred as multiple access protocols. Here we have different types of multiple access protocols like random access, then we have controlled access, then we have channelization protocols. In random access, we will be discussing about protocols called pure aloha and slotted aloha. In the controlled access, we'll be talking about token passing. Then in your channelization, we'll be talking about TDMA, CDMA, and FDMA. And with this, we can have an understanding of how a particular channel will be shared among multiple users. And last unit, we introduced about 802.11, which is called Wi-Fi. Here we will try to understand its frame and protocol. Okay. This is what we are going to introduce in unit number 2. After going through unit number 2, we would be moving ahead to the third layer of OSI model called network layer. Now in network layer, as we said, the major function to be performed is routing of the packet from the source to destination. If the source and destination are very far, then the data has to be transmitted through a long distance. It has to travel through a number of intermediate devices. Now, how this data will be transmitted from the source to destination will be decided by the routing algorithms. So the network layer majorly will be playing a key role in the routing of data. Now here, when you're trying to send data from source to destination, we have three different possible types of networks. When source and destination are implementing circuit switch network, then between the source and the destination, we are going to have a dedicated path. So before transmitting the data, a dedicated path has to be established between source and destination. If the dedicated path exists between source and destination, you are going to refer that type of networks as circuit networks. Got it? So one thing to be remembered here is in circuit networks, before you exchange the data, a path has to be established and the entire data is going to be transmitted through the same path. That is called circuit network. And this circuit will be exclusively used for source to destination. Means what? In 1 hour, if I am transmitting data for 3 minutes, and for entire 1 hour, only 3 minutes the circuit is being utilized. So remaining 57 minutes is unutilized. So to overcome this particular drawback, because you remember the bandwidth or the channel which we are using is very expensive, and it will be useful only when it is utilized effectively. So to overcome this drawback of circuit switching, we are going to implement the other kind called virtual circuit. Here also you have a path between the source and destination, but the only difference you will have is this particular path is not only shared between source and destination. One, we may have more than one device like S1, S2, S3. At the same time at the destination you will have D1, D2, D3. Now which device will be using and which particular time will be discussed by or identified by the multiple access protocols which we have discussed in the previous unit. Clear? Right. Then along with circuit and virtual circuit, there is one more path. For instance, I have source to destination, and for this we have between source and destination, I have more than one path. 1, 2, and 3. Okay, so there are totally 3 paths between source and destination. Now here what happens is the total data to be transmitted will be divided into smaller units called datagrams, and different datagrams are going to choose different paths. For instance, I totally have a data called small in I use the alphabet D1 or small letters A, B, and C. So my total data is divided into smaller units called A, B, C, and packet A transmits through path 1, packet B travels through path 2, and packet C travels through path C. So what is the advantage here? It happens is the amount of time it takes for transmission will be less compared to the previous 2 networks. And second important thing that can happen is if one of the part got congestion or or the network got breakdown, we have alternate paths through which the data can be transmitted. So this is an advantage of having a datagram networks. But what is the issue? The total data transmitted is divided into smaller units called ABC, and there is a possibility that at the destination you are going to receive the data in different format. Instead of ABC, I'm going to receive the order like BCA, and I have to rearrange the data before I transmit to the higher layers. Okay, so this is the three different types of networks which will be used in routing: virtual circuit, datagram networks, and the first one called circuit networks. And for implementing of this routing function by the network layer, we are using an intermediate devices called as routers. A router is a device which receives a packet through its input port, then it forwards to its switching unit, in which it takes the support of a routing processor, determines from which output port the data has to be transmitted, and then it will be forwarding to the corresponding output port. Okay, in case if output port has forwarded to the next, but there is a congestion in the network, those packets will be waiting at the queuing mechanism. So totally a router comprises of input processing, switching, then processor, queuing mechanism, and output port. Okay, so I hope this particular function is clear, and we are going to understand. We are just trying to give you a brief about it here, but in detail about each of this we'll be trying to understand in the inside a router concept. Okay, now one of the most important thing which we have to know in the network layer is about the protocol used in internet network layer called internet protocol, and the address concerned with the internet protocol is called IP address. Now, when I say about a word called IP address, everyone says, yeah, I heard about it. Correct? Right. So whenever you want to connect to yourself to an internet, you need to have an IP address. Okay. So IP address is also referred as universal address. The reason is simple. Once you are trying to send message from a device in Hyderabad to someone who is in Delhi, in between you may be transmitting through number of routers, but no matter the number of nodes involved, but the IP address will not change. But in the data link layer which we discussed, we are going to have a MAC address which will be changing from node to node. Okay, right. So next, currently we are using a version of IP called IPv4, which is a 32-bit. Problem with the V4 is it is having a restriction on total availability of IP address. With IPv4, you have total 2 power 32 IP addresses, but growing demand make this 2 power 32 number insufficient. So we are opting for the next version of IP called IPv6 with a capability of 2 power 128. So we are going to learn about IPv4, IPv6, and we are also trying to compare those two versions of IPv4 and IPv6. Now, sometimes when you try to send a message or you want to send a mail and you got some wrong in the mail address, then after a few minutes you will get a response that a failure in the mail sending. Now this indicates the sender that because of some reason the particular destination address was not identified and you are alerted that the data was not reached successfully. Now those kind of alert or a control mechanism to indicate about the error in the transmission will be implemented by a protocol called Internet Control Message Protocol. Okay, so I hope these are the things that we are going to understand in our unit number 3 called network layer, right? So first we'll start with what do you mean by forwarding and routing. Then we are trying to understand the 3 different types of networks called circuit, datagram, and virtual circuit. Then we are trying to understand what is a router and what are the different elements of inside a router. Next, we are trying to understand what do you mean by IP, what are the 2 versions of IP, and then a comparison between the 2 versions, and last but not the least, one of the important protocol in the network layer called Internet Control Message Protocol. Okay. fourth unit which we deal in the subject is called as transport layer. And as we discussed in the in the beginning, that we not just want a source to destination delivery, but we actually would like to implement a process to process delivery. Application to application delivery is required. For implementation of application to application delivery, we are using the service of transport layer. So first here we will try to understand what are the services which our transport layer is taking from the network layer and the relation between them, and then how transport layer is implementing this process to delivery. And in the process we are learning a concept called multiplexing and demultiplexing. So what do we mean by multiplex? For instance, we talk about carpooling, right? So what happens? Individual travelers would like to go to a common place, but they are not able to afford to have an individual vehicle. So what they do? So two or three people who have the common purpose of traveling, but don't want to spend or don't have a resource, would like to share the resource by traveling together. Correct? So three individual resources. Here we have 1, 2, 3. They will be combined during the travel, like 1, 2, 3 in a common car, and again at the destination they will be split back as 1, 2, 3. But during the journey they travel together. So combining of multiple units into one, that is many to one, is called multiplexing. And at the receiver we are going to have one to many, called as demultiplex. So we are going to understand what do you mean by multiplexing and demultiplexing, and how transport layer will be implementing this multiplexing and demultiplexing phenomenon. Now when you are trying to implement process to process delivery, we have two modes. The first mode is where you just want to implement process to process delivery, and you are not much keen about how reliable the path or the transmission is. So when you are least bothered about the reliability and accuracy, and what all you are looking is only a process to process delivery, and remaining reliability will be taken care by other layers in the network, then the type of protocol we are going to use is called user datagram protocol. But when you hear this word, you are a bit worried. I'm not sure whether my data is going to be transmitted successfully or not. But when you care about whether I want definitely a reliability in the transmission, then you have to opt for the other alternative transport layer protocol called transmission control protocol. And remember, the user datagram protocol, which is unreliable, is actually a connectionless transport layer protocol. And then reliable oriented and a protocol of transport layer called transmission control protocol is a connection oriented protocol. In the last unit we were talking about a concept called congestion, which refers to a jam or traffic issues in the network. To overcome those, we are going to adapt some of the control mechanisms called congestion control principles, which we are going to understand in principles of congestion control. First, what are the reasons for congestion and how do we overcome those congestion concepts will be discussed in principles of congestion control. And last unit of our syllabus is application layer, and here we are going to discuss about what are the different application protocols which we are using in common life. For instance, as we discussed, when you have been for application layer is actually trying to get some services from the network layer and the transport layer. That is what we are going to first understand in the application layer. Then we are going to understand some of the important application layer. So we are first trying to understand what a network layer provides to the application layer, and then we're also trying to understand what are the services transport layer provides to the application layer. Okay, then the major protocols which we are going to learn in this subject are in this particular application layer are file transfer protocol, which helps you to attach a file at the same time to download a files. And next we are going to understand about how we send mails and receive mails using a protocol called simple mail transfer protocol. Then the web address or the website address which you type is basically referred as DNS, domain name service. We are going to talk about it and how it works. For instance, it's a simple like our college website, www.aceec.ac.in. It's a domain name service. Okay, so which indicates the domain, the website name have different individual elements, each having its specific. World Wide Web, ACEC refers to our college name. Then .in indicates our country of operation, and AC refers to the generally foreigners. Okay, so we are going to understand this different elements of your website through DNS. Okay, now I hope sorry, pardon. So here is a quick understanding of it, or we can say a brief introduction about the different topics which we are going to discuss in our course called Data Communication Networks. And we would be understanding the importance of the subject when we know the application of data communication networks in different entities. Where do we use this data communication networks? First, airports and airplanes. We find a lot of communication happening between the flights and the control stations. Same time, you can find we have a lot. We have been doing flight booking from home, or we are from websites and all from mobile phones. A lot of data has been exchanged. We need to get a status of what are the flights available, how many seats available, how do we select it, and then once we select a seat, that need to be updated in the complaints website. All these things need to be done. We do net banking, phone banking. We have been reduced from the burden of going to the banks and stand in the queues. Or sometimes you say ATMs can help you, and whenever you do a transaction in ATM, that need to be updated in the your account details of the bank website. All this to be done. A lot of data is exchanged in colleges. Through its websites, and you find in the libraries, you find a lot of data. What are the books available, what are issued, what are where do we find the particular books, for how many volumes of books are available. All this stuff you'll be having a lot of data communications, right? And in the medical industry also, you have been using the data communications, and one of the most important application you talk about is called e-commerce. This is a buzzword, and recent times you find e-commerce is growing like anything. Amazon, Flipkart, and we have number of other e-commerce sites which you would like to access. Alibaba. So all these kind of websites, we are trying to make a lot of shopping, and we can name something more than this. Big Basket. All these are the e-commerce sites which can be helping us to buy things without even going to the particular places. And factories, they have been implementing something called total quality management, supply chain management, just-in-time inventory. All these things are happening only when they can know what is the stock available, how much stock has been dispatched, when the raw material has to be obtained, and when is the order to be delivered. All these things need to be automated, and the data has to be available. And all this is possible with the implementation of data communication networks. The city office should know about the status of the inventory available in the plants, and at the same time, the orders which are generated by the city office need to be known to the plant, so that accordingly they start the manufacture. All this stuff requires a lot of communication, and this happens only when data communication network has been established, right? So understanding what are the contents of the data communication network and the applications of it, I hope people will realize that this is one of the subjects not only useful for JNTU aspect, for a number of real-time scenarios and applications. To make you more create more interest for you people in this subject, let me tell something, that this is not just sufficient for understanding real-time examples or university syllabus, but if you want to have more understanding of the subject and more knowledge on it, then you got something called certification courses in network. This, people, please do remember, we got something called certification courses in networking. On completing of this, there is an opportunity that you people will be getting careers in the field of networking. What are the different courses you find in related with networking? First, we have a course called Cisco Certified Network Associate, then Cisco Certified Network Practitioner, then we have CCIE, we got CCIE course, then Cisco Certified Network Professional, Cisco Certified Internet Work Expert, and then Cisco Certified Architects. Along with this, we also have professions like Amazon Web Service Solution Architect or Microsoft Certified Solutions Architect. All these are the different courses which you people can opt, and by completing of this course, there's a definite chance that you get some wonderful career opportunities. Let me once again tell you, these are some of the best courses which you can do if you want to have a career in the field of networking. Cisco offers majority of the courses, but you have even in other fields like Amazon Web Services is offering a course, and the Microsoft is also offering a course, and you people do it and get certified. There's a very good chance that you will make a wonderful career in this platform. And let me show you something interesting which creates interest for you in this learning of the subject and in detail in the future called so in you here you can find different courses related with Cisco. So this is what I try to show you people, and at the same time the Amazon certification course and Microsoft certification course, right? I've been talking to you people about wonderful career opportunities in networking. Let me make you just show something which makes you interesting, that when you people opt this certification and do it and start a career, then you have different profiles related with networking. You can start your career called network engineer by doing certification courses in CCNA and CCNP, where you can start with fundamental salaries, but you believe from 20,000 you can even earn up to 70 plus thousand in a month, and this is the beginning position. And when you get 2 or 3 years of experience in this networking field, then you move to a profile called senior network engineer, and here you can even earn a salaries up to 18.5 lakhs, right? And after some more years with more experience and more certifications, as we said, Cisco Certified Network Associate and Cisco Certified Network Professionals, and getting more experience, you can become network administrator with this profile, and you get a package up to 11 lakhs, or you get a profile like network security engineer, and where the package can range up to 22 lakhs, and a network architect with over 5 years of experience, you can make yourself to a career where you earn 40 lakhs per annum. Now that sounds good for people, right? So people who are really finding interesting in networking and try to understand or make a long career in this, make sure you understand the subject in detail beyond your marks and credits. Then you try to do some certification courses. Later you can start career with a smaller package, but definitely in less than 5 or 6 years you can go to a wonderful position. I hope this introduction class makes you an insight on what is the subject, what are we going to learn about it, and post learning the subject, what are the courses which you can opt for a deeper understanding of it, and later what are the different profiles of careers available in the field of network. I believe I give you the best of my inputs regarding the subject and its future prospects. However, in the next class we'll start our syllabus with introduction to data communications, and believing that we will have the best of the learning. Thank you, one and all.